Good afternoon. My name is Ryan Peluso, and this is my Secure Network Architecture Design Project. Today I'll be covering the corporate infrastructure diagram, the GVM full and fast vulnerability scan, and the security issues associated. Here you can see router 1 and router 2. Router 1 connects to switch 1, then to switch 2, and then to the DMZ switch, which ultimately creates the DMZ zone here. The router 2 will connect to the intrusion detection and prevention system, which will continuously monitor for potentially malicious activity on the network and will provide real-time alerts to network administrators if there is any suspicious activity. The proxy server will manage the internet access and store temporary files with both hardware and software components, as well as caching frequently visited websites. The network will then be divided into smaller subnets so that each department will be isolated from the other departments. Here you can see the proxy server is between the intrusion detection system as well as the DMZ. And then below, you can see here are some of the departments, here and here, and here are 3 others. They are all on their separate networks. IP addresses are assigned to the network devices via the DHCP server and will be air-gapped to the computers not linked to the internet or any other network and provide additional security. The connecting between the internet and router 1 can use virtual private networks and accommodate remote access and regulate traffic flowing within the 2 networks. The connection between router 1 and router 2 is through switch 1, while router 2 is connected to the DMZ switch and creates a demilitarized zone shown in green. The DMZ will create a safe environment to securely access the email and proxy server. So again, here you can see the DMZ, where the mail server as well as the web server are contained within this area. The intrusion detection and prevention systems will be able to identify and alert an analyst of network modifications or potential malicious activity. This will allow administrators to correct found vulnerabilities before they become a bigger issue. Emails will be contained within the mail server and ensure the communication between members remains safe. So again, here's the intrusion detection and prevention system, and they are connected between the router 2 and proxy server. And then again, the mail server is within the DMZ. By dividing the network into smaller subnets within each department will prevent them from having access to each other's files. This is crucial as it will prevent users from other sections from accessing, modifying, or deleting their files relating to each department. This security enhancement will protect individuals' privacy and keep unauthorized users out of personal information that they should not be accessing. Lastly, the DHCP server will assign IP addresses to the devices on the network. The R&D department will be air-gapped, where there is no connection to the internet or any other network. This prevents malicious activity coming from outside attackers, and this will also greatly enhance security and protect the information from being easily accessible. Again, here is the DHCP server, and it is connecting to all the other departments as well as the air-gap system. Here is the GVM vulnerability scan, and this report shows that there is a medium risk somewhere within the VirtualBox infrastructure and identifies IPs and the locations of the TCP. Since it is shown as a medium severity, they are important and action should be taken to correct the issues as soon as possible. Further looking into the report can provide more information relating to the vulnerability. Down here it is giving us more information. As you can see, the type of vulnerability, the IP address, and then the location of the vulnerability. The vulnerability itself is associated with the DCE/RPC and MSRPC services enumeration reporting. This can be corrected by adjusting firewall settings. Blocking port 135 should help in remediating the vulnerability. There are a lot of existing protocols such as routing, mail transferring, and distant communication. Network protocols ensures data security and integrity within a given network. It can utilize different strategies to protect the data from unauthorized users who may be trying to gain access. Wireless access points are created through wired networks and allow different devices to connect in a seamless manner. Devices will show a list of the access points within range, allowing the user to select from. Take caution though, as some wireless networks are not trustworthy. Any network connection that can be easily accessed by anyone can be a security risk and lead to personal information or documents being unknowingly stolen. Networks with some form of authentication or require passwords tend to be more secure and could prevent unauthorized access. The Internet Engineering Task Force defines operating internet protocols known as TCP and IP. The workgroup also provides information relating to data authentication, integrity, and privacy among entities. Cryptographic keys can be set manually as well as dynamically using Internet Key Exchange. Security socket layers are used to maintain a secured internet connection and safeguard sensitive data between the systems. This prevents unauthorized users from reading or altering personal data, packets, or details within a network. Finally, the Protect Shell is a cryptographic network security protocol and is a secure data exchange across the network. It enables remote access to the command line and remote execution of certain tasks. SSH incorporates several FTP-like features, and SSH1 and SSH2 are the most recent versions. Today I covered corporate infrastructure diagram, the GVM vulnerability scan, and security issues. Attached are the references associated with my research, and I want to thank you for your time for watching this.